Hello, good morning. This is Nas from NB Network Lessons. Hope everyone's doing okay. Welcome to all of my calculus lovers. This is lesson number 69 under advanced calculus, and we're going to see another representation of polar coordinates. In case of Cartesian, let's say you have a point x and y. You cannot represent that point any other way. Say, x is 1, y is 2. That is it. You cannot represent that particular point in any other way, but that is not the case when it comes to polar coordinates. Let's see how. So let's say you have 1 and pi over 2, and we would like to plot these. As you recall, in polar coordinates you have r and then you have theta, right? And in Cartesian coordinates you have x and y, and that's it. You cannot change this. This is non-changeable. Whatever your point have on the graph, that is it. But in case of Cartesian, in case of polar coordinates, you'll see that we can have variety of different representations. So I'm going to go ahead and see if I can draw this. So you've got x-axis and you've got y-axis. Let's see if we can draw this. Pi over 2, which is 90 degrees. Right here is the angle, pi over 2. All right. So what's the length? Length is given 1. So this right here, this distance right here, from here to the origin is 1. Okay. So then what we can say is this point right here is, in terms of polar coordinates, 1 and pi over 2. No dispute to that, right? Now, question is, can we represent this in another way? Yes, we can. Remember, if you recall from our last lecture, what I told you that, basically, if you have right here and you go around and you come back, you can add 2 pi. You go around and come back again, you can add 4 pi, okay? So then what we do is that we say, okay, one way of representation is 1 over pi over 2. Another representation, this is representation number 1. Representation number 2 would be another 1 pi over 2 plus 2 pi. I'm not really changing the point, right? What I'm doing is that this is my point. I'm just saying, okay, let me do this. Let me go around this way and then come back right here. So that's adding 2 pi, all right? So then if you solve this, you get 1 plus pi over 2. And then what I do is that I multiplied and divide this by 2 so that I can have the common base, common denominator. So if I multiply this by 2, that becomes 4 pi and divided by 2. So then I know I can say answer is 5 pi over 2, right? So I can represent this like this. Now the question is, okay, so 1 over 5 pi 2 is this point. 1 comma pi over 2 is this point. I can go one more time. I'm already here. I can go one more time. So let's say representation number 3. So we have 1 5 pi over 2 plus 2 pi. All right. So we can have this representation also. Now if you add this, you get 1 5 pi over 2 plus, I want the base to be the same, so I'm going to multiply this. Actually, this is going to be 4 pi or 2 pi. Yeah, 2 pi, because I'm adding 2 pi again. So then that is going to become 4 pi over 2. I'm multiplying and dividing this by 2 so that I can have the common denominator. So then the answer is 9 pi over 2. Okay, so this is the same. This represents this point right here. This represents this point right here. This represents this point right here. Can you do that in Cartesian? No. But in form of polar coordinates, you can do that. And trust me, when you become scientist, when you become engineer, when you become mathematician and you're doing the real practical work, you're gonna be using this. I promise you. Thank you so much for watching. You all have a wonderful day. I will talk to you next time. Take care of yourself. Bye.